One-step equations. You guys have seen equations in class, and all an equation is a number sentence that has an equal sign in it. Hence the name equation, means that there are two different sides that are equal to each other. Vocabulary. Inverse operation. That is pairs of operations that undo each other, or opposite operations. Okay, so we've got addition and subtraction. Those are opposite of each other, and if you were to subtract something that was added, it would undo what you had just done. Multiplication and division, those are inverse operations. And then we've got a number squared versus the square root. If you take the square root of something, it's the opposite of squaring it. In equations, we have a variable. A variable is a letter that is used in the equation that has some sort of numerical value. For instance, here, x plus 3 equals 9. We don't know the value of x, that's why we give it a variable, but we can figure it out. So how do you solve a one-step equation? You have to perform the inverse operation. So the inverse operations that we just talked about above, you have to perform it to isolate the variable. Now, isolate means to get the variable alone. Taking a look at this example right here, x plus 3 equals 9. We want to get this variable x all by itself, which means I have to get rid of the 3. So the inverse operation of adding 3 is subtracting 3. And whenever we are doing the inverse operation, you have to make sure you do it to the left side of the equation and the right side of the equation. So the equation is broken up into two sides. You got the left side of the equal sign and you got the right side of the equal sign. It's much better to explain just basically showing you. So I've got this example right here, x plus 3 equals 9, and then I have it modeled. This is what stands for an x, and then we've got 3 positive integers, so x plus 3 is equal to 9 positive integers. So if we're going to perform the inverse operation, you'll see x plus 3. I'm going to take away 3 because that is the inverse operation. And you have to do that to both sides of the equation. I'm going to draw a little line right here so that you can see that there are two sides. You got everything on the left-hand side of the equation. You've got everything on the right-hand side of the equation. So if I've got plus 3 and then I've got subtract 3, well, that kind of goes away. If you're adding 3 to something and then you take away 3, well, all you're left with is this x. So x is equal to 9 minus 3 is 6. That's how you solve just a regular equation, but I've got the same equation over here modeled. I'm going to do the same thing. I subtract 3 from both sides. So how do we show subtraction in a model? You cross it out. So I cross those 3 out. I cross these 3 out. I cross out 3 on the left side, cross out 3 on the right side, and I'm still left with x is equal to 6. So it didn't matter which method I used to solve that equation, my answer is still x equals 6. Here's another one. X plus 5 is equal to 8. I'm going to separate my equation into my two sides. It says x plus 5. The inverse operation for addition is subtraction, so I'm going to subtract 5 from here, subtract 5 from here. Now I'm left with x, because my 5 went away, is equal to 3. Now, there's always a way you can check your answer. Take this, the value of x, and plug it back in. If I substitute x with 3, 3 plus 5, it is in fact equal to 8, which means I've done my problem correctly. Over here, I've got a modeled equation. It doesn't matter what shape you use for x as long as it's labeled. So over here, I subtracted 5. Over here, I've got my triangle that represents x, and then I've got some positive counters. Anything that you see that is the same on both sides, you've got to get rid of. So I'm going to cross out 5 on the left-hand side, cross out 5 on the right-hand side. Whatever you do to one side, you have to do the other. And I'm left with x equals 1, 2, 3. X equals 3. So it didn't matter which method I chose to solve, I still got the same answer. Got some more models. X minus 4 equals 6. So I've got a subtraction equation here. What is the opposite of subtraction? Addition. So I've got to add 6. Add 6. I'm sorry, not 6. What am I thinking? 4. 4 is subtracted. Now I got to add 4. 4 is subtracted. Now I've got to add 4. So I'm just left with x equals 6 plus 4 is 10. Okay, x is equal to 10. Now I'm going to take that 10, substitute it back into my problem. 10 minus 4 is in fact 6. Over here, what would I do to this? I would add 4. I'm going to add 4 here too. 1, 2, 3, 4. 1, 2, 3, 4. I added 4 to both sides of the equations. Whenever I added it over here to the left, I created 0 pairs. So 0 pairs cancel each other out, and I'm just left with x equals 10. There are some equations that cannot be modeled. You can always model addition and subtraction equations, but multiplication and division equations are a little bit harder to be modeled. It can be done, but right now we're just going to focus on how to solve those. This right here says 5d equals 30. Means 5 times some number is equal to 30. Well, you guys know that 5 times 6 is equal to 30, but what if the numbers are so big that you cannot figure it out in your head? Remember, inverse operations, since this is multiply, we have to divide by 5, divide by 5. So 5 divided by 5 is 1. All you're left with is d equals 30 divided by 5 is 6. Okay, let's plug it back into our original problem. 5 times 6 is in fact equal to 30. Same thing over here. Negative 6m is equal to 60. Divide by negative 6. Divide by negative 6. M is equal to 60 divided by negative 6 is negative 10. Now guys, we've worked on integers before. Those negative signs are important. You cannot leave it off and expect to get the right answer. So let's plug it back into our original equation. Negative 6 times negative 10 is a positive 60 because a negative times a negative is a positive. 2 times x is equal to 18. So we divide by 2. Divide by 2. X is equal to 9. Let's plug it back in. 2 times 9 is 18. Negative 5p is equal to negative 25. Divide by negative 5. Divide by negative 5. P is equal to positive 5. Negative 5 times positive 5 is a negative 25. Those are multiplication equations. Here are some division equations. This says some number divided by 2 is equal to 8. So what's the opposite of division? Multiplication. So that's how we solve it. Multiply by 2. Multiply by 2. We're left with x is equal to 16. Let's take that x and plug it back into our original problem. 16 divided by 2 is in fact 8. Okay, we've got b divided by negative 2 is equal to 30. Multiply by negative 2. Multiply by negative 2. We're left with b is equal to negative 60. So negative 60 divided by negative 2 is a positive 30. Now this one looks a little bit different. 1/3 x. 1/3 x equals 15. Now it kind of looks like a multiplication problem because those are right beside each other. But think about if you're taking a third of something. Well, if you're taking a half of something, aren't you dividing it by 2? Same situation with a third. If you're taking a third of something, you're breaking it up into 3 sections. You're dividing it by 3. So to solve for this, it is times 3 times 3. We're left with x equals 45. So if I take a third of 45, it is in fact 15. M divided by negative 6 is equal to negative 4. So opposite, multiply by negative 6. Multiply by negative 6. M is equal to positive 24. Plug it back in. 24 divided by negative 6 is a negative 4. Okay. In summary, When solving an equation, the goal is to find the value of the variable or the unknown letter. To isolate the variable, you have to perform the inverse operation. Inverse operations are add and subtract, multiply and divide, and square root.